Good day, students. Welcome to mathgotserved.com. And this clip we're going to be going over how to solve separable differential equations. This standard is covered in calculus, differential equation, and physics courses. Don't forget there are 2 practice problems at the end of this presentation that we'd like you to try out in order to demonstrate mastery of the contents covered in this tutorial. Alright, the instruction for the example that we're working on in this presentation is to find the particular solution. Find the particular solution of the differential equation with the given initial condition, okay? With the given initial condition. Okay, so let's say for number 1, we have the differential equation dy dx equals 2x root y, and the initial condition is y of 0 equals 1. Okay? Alright, so this particular differential equation, we're going to solve it using the method of separation of variables. Okay, that's the familiar method. It's very common to come across this particular type of differential equations on the AP Calculus AB exam. Alright, so to solve using the method of separation of variables, we're going to use the sci-fi I approach. Okay, so what does sci-fi I mean? Well, is the steps that you go through. Okay, so S basically means that you separate your variables. In this particular case, f of y and y would be on the left, and f of x and x would be on the right. And then the I means you integrate, so you're going to integrate both sides of your differential equation to get rid of dy and dx. And then when you integrate, you're going to end up with a c value. And then that's where the f comes in. F basically means you're going to have to find what that c is. You're going to find c using your initial condition, y of 0 equals 1. And then I, you're going to insert that c back into the equation. And then for iy, you just basically isolate y. When y is isolated, you then have the particular solution of your differential equation, okay? There is a general solution, which doesn't involve the isolation of y. And then you have the general solution basically has a c in it, and then the particular solution that's explicit has y isolated and no c component. Okay? All right, so let's go ahead and get started. We're just going to follow the steps that we have outlined here. So for part 1, we are going to separate. Okay? Do the separation of variables. So we have dy dx equals 2x root y. So I need the y's on the left and the dx is on the right. So to move dx to the right, I will multiply both sides by dx. Okay, and that will leave me with dy equals 2x root y dx. And then to move y to the left side of the equation, I multiply both sides by 1 over root y. Okay, so 1 over root y, 1 over root y. Okay, so we now have 1 over root y dy is equal to 2x dx. Now, what have we accomplished so far? Well, we have successfully separated the variables. The y is on the left and the x is on the right. Okay, so we're done with the S step in sci-fi I. Next, we're going to integrate, okay, to get rid of these differentials that we have here. So we're going to integrate. Now, if we want to integrate 1 over y, it's going to be complicated. We have to rewrite it using the the reciprocal property of exponents, and also nth root property, the special case of the nth root property. So if you write this as a power, it's going to be y raised to the negative 1/2. Okay, the 1/2 is for the square roots, the negativities as a result of reciprocation. Okay, when we reciprocate a term, the sign of the exponent changes. All right, so y to the negative 1/2 dy equals factorial 2 integral of x dx. Okay, all right, so now we're going to proceed to use the power rule to integrate both sides of our equation. So if we integrate the left side, we're going to have y raised to the negative 1/2 plus 1, which is 2/2, divided by the same thing, negative 1/2 plus 1, which is 2/2. And then if you integrate the right side, you have 2x squared over 2 plus the constant c. Okay. Okay, so let's go ahead and simplify this. So this is going to become y, it's going to be y to the 1/2 over 1/2 equals, and then we can divide these two 2's, x squared plus c. Okay, and then let's see what we can do here. We can then proceed to simplify this further. You drop change flip, so you have 2y raised to the 1/2 power is equal to x squared plus c. Okay, so we're done with the integration step. Next part is to find c. So how do we find c? We're going to find c using the initial condition, which is y of 0 equals 1. Okay, so what does that mean? Basically means that when x is 0, y is 1. Okay. All right, so let's go ahead and plug these two into this equation and solve for c. So we're going to have 2 times 1 raised to the 1/2 equals 0 squared plus c. 1 to the 1/2 is the square root of 1, which is just 1. So 2 times 1 is 2. 2 is equal to c. Okay, so next we're going to insert c. We're going to insert c into the answer that we got here, right there. So we're going to have 2y to the 1/2 equals x squared plus 2. Okay, so what we have right now is the implicit particular solution. Okay, so let's specify exactly what we have. This is the implicit particular solution. But we gotta make it explicit. We need to have y isolated, okay, and then we'll be done. Over here, this equation that we have up here, this is the implicit general solution. All right, implicit general solution. The difference between the particular and general solution is that for the general, c is unknown. Okay, any c value can be substituted to get a solution with the initial condition, but for the particular, it means that you're picking a specific c value in this case too. Okay, all right, so let's make it particular. We need to get y by itself, so we are going to carry out the last step, which is to isolate y. All right, so let's go ahead and isolate y. All we have to do now is just algebra. There's no more calculus steps involved. So we have 2y to the 1/2 equals x squared plus 2. All we're going to do now is just divide both sides by 2 and find the square. Okay. All right, so let's do that. So if we divide the entire equation by 2, we have y to the 1/2 is equal to x squared over 2 plus 1. And then the inverse of the 1/2 power, or the square root, is the square. Okay, so raise both sides of the equation to the second power. And that will result in the isolation of y. So we have y equals the quantity x squared over 2 plus 1 raised to the second power. And this, ladies and gentlemen, is the explicit particular solution. This is the final answer that we're looking for. Alrighty, ladies and gentlemen, it's now your turn. We have two practice problems that we'd like you to try out. So the instructions are basically the same as the example we just did. We'd like you to find the particular solution of these differential equations using the initial conditions provided. Go ahead and pause this video presentation at this time. When you're done solving the problems, reinitiate playback in order to see what the answers are. Alrighty, welcome back. So hopefully you had a chance to try out the problems. The solution to question number 1 is y equals the cube root of 3x to the 4th over 2 plus 2. And then for number 2, the particular explicit solution is y equals negative 2 over the quantity x squared plus 2. Okay, so how well did you do in solving these two problems? Let us know in the comment section below. And if you like assistance or clarifications on what we covered or any of these two problems, just post your questions in the comment section below and we'll be glad to support you. Thanks so much for taking the time to watch this presentation. Really appreciate it. If you found the contents of this tutorial helpful in your studies of differential equations, to give us a thumbs up. Your positive feedback is very valuable to us. As indicated earlier, if you have any questions or comments, just post it in the comment section below and we'll be more than glad to assist you. Don't forget to subscribe to our channel. We upload videos to our page on a regular basis. More support resources can be found at our website, mathgotserved.com, or just take a look at the link in the description below. Thanks again for watching and have a wonderful day. Goodbye.